We are now recording, and we're recording this mess. Let's get rid of it. And let's go from current slide, if I can get it to come up. Now, let me make a couple of announcements. I think you've heard at least one of these before, maybe both of them. Over the weekend was midterm. Sometime over the weekend was smack dab middle of the term. So we're in the second half of the term right now. If any of you were in a first mini-term course, you hopefully passed that course. And if you are starting a second mini-term course, that will begin this week. Okay? So if you did schedule one, don't forget to go. I know it can sneak up on you sometimes, especially that second mini-term. And Emmett is here. There. Okay. And what that means, and I think I told you all this before, is that they typically ask for midterm progress reports, which means they want to know students who have D's or F at midterm. Now, I haven't looked at all the grades, but I'm guessing all of you are in pretty good shape. Nothing sticks out to me as somebody who might actually be failing or even a D at midterm, but I haven't looked at the numbers. But in any of your other courses, the same thing is going to be requested, so be sure if you have something you could turn in that would help. And for this course, maybe that research paper, hint, okay? We're half the term's over with, and I don't have half the papers yet, so please, folks, try to get those worked on. Don't let those sneak up on you and get behind on that. And but other than that, I think this class is probably in the best shape of any of my classes as far as midterm progress reports, because y'all got that first quiz and test in great shape. It's only if you did pretty poorly on that, and I don't recall anyone who did, but I might be wrong. So anyway, that's happening this week. Another thing that's happening this week are my office hours are changing. First mini-term, I had a physical science course that was on the first mini-term. It started at 1:15 on Tuesday, Thursdays, and went until 5:45, okay, because it's class and lab, so it's a long little class. Okay, second mini-term, that physical science class can't start at 1:15 because some of the automotive students are in it, and they don't get out of their block schedule until 3 o'clock. So therefore, that second mini-term physical science class will start at 3:15 and go till 7:45. So what that means, my Tuesday, Thursday office hours are now expanded. It used to be 11:15 to 1:15. Now it's 11:15 till 3:15. So I've got twice as many office hours, or twice as long of office hours on Tuesdays and Thursdays as I did before. With one exception, and that's tomorrow. Tomorrow I have a doctor's appointment. I think I may have told you all this early in the term, that I would have an appointment some Tuesday this term, and it's tomorrow. And it's at 10:40, which means I have to have labs at 9:40, which means I have to leave campus by 9 o'clock. So it won't affect this class any, but it will affect the other. Kayla, okay. That's Stinson, right? Okay. Okay, I've got to sneeze. Sorry. All right, y'all awake. Good. But with the appointment being, excuse me. Where is this coming from? I don't know. It must be allergic to Emma here or something. I don't know. All right. Again. Sorry. All right. That means with my, sorry. Maybe it's Kayla. She just came. No. All right. Second. Sorry. Goodness gracious. This has been going on a while. It's nothing new. Okay. All right. All right. Maybe one of these days it'll stop. All right. And there was lecture. Okay. Folks, I think I'm going to have to run down the hall and clear my head, so I'm going to pause the recording. I was talking about changes of office hours this term, mini-term, but I was talking then about changes for tomorrow. As I said, normally it'll be Tuesdays and Thursdays, 11:15 to 3:15 from now on, but not tomorrow because my appointment's at 10:40. I don't think there's any way in the world I'll get out of there before 11 o'clock. If I get out at 11, then it'll be at least 11:45 before I'm back here on campus. So I won't be here at 11:15 tomorrow. Probably more like 11:45 or maybe even noon or later. Depends on how far they get behind before my appointment. Mine's not going to take any time, but they do get behind. All right, so after that, it'll be Tuesdays and Thursdays, 11:15 to 3:15. All right. Can't think of anything else. So any questions on anything we've covered so far or any types of questions? All right. Where we left off last time, I still can't talk. Let me say this. We are about the midpoint in this module, so the quiz I've got ready for you. So if you do have to leave early, pick up a quiz before you leave, okay? The rest of you get them before you leave at the end of the class. All right, any questions on what we've done so far? Now, if you recall, we were adding or subtracting rational expressions, okay? And what's the deal that you have to go through when you're adding or subtracting rational expressions? Just as adding or subtracting fractions, which are rational numbers, what do you have to do? Oh, it's been a long time. Say again? Okay, that's good. Good answer for just about anything in this course is factor. Okay, so you got it. As I tell some of my classes sometime, and this, if y'all don't take it poorly or anything, but our church usually has, right before the sermon and stuff, they have children's church. So all the kids that come forward. And someone will be out front, one of the pastors or a leader or something like that, and they usually start by asking the kids a question. Of course, the kids sit there and go, no clue. Finally, some kid in the back, usually a little boy in the back, will say, Jesus, because they figure any question they ask in church, Jesus will be a good answer. So, not a bad answer in this course, factor, okay? So, yeah, that's the Jesus answer here. And yes, we will sort of be factoring, but for adding and subtracting rational numbers, the answer is, okay, not in this case. We will be doing it some, but it's common denominators, okay? Adding or subtracting rational expressions, you have to have common denominators. So, in this first one, what's common among those three denominators? And it's not just what's common, but what's the least common thing. Okay, set it up just like it is. What's the least common denominator between those three denominators? Say again? 12, you got to have a 12 in it. And an x, exactly. It's going to be 12x. Okay? Now, what did you have to do to get this denominator, the x, to become a 12x? Multiply by 12, okay? If you multiply the denominator by 12, what had you better do? Multiply the numerator by 12 as well. So the numerator becomes 12y. Perfect. Okay, to get this denominator to be 12x, what did you have to do? multiply by 4. If you multiply the denominator by 4, what had you better have done? Numerator by 4 as well, so it becomes 16y. To get this denominator to become 12x, what did you have to do? Multiply it by 3. If you multiply the denominator by 3, what had you better do? Multiply the numerator by 3 as well. And that gave you 9y. Okay? And then all it takes, now that you have common denominators, 12x, we'll just put them all over that. What's your new numerator? A little louder. Someone may have said it, I just don't hear well. 5y. Why not? Good deal. Make sense? Okay? Now that's one way to do it. There are other ways to do it. When I was growing up, here's how they say. They take this denominator and say x will go into 12, 12x, 12 times y is 12y. That does the same thing. Okay? Let me get your name, please. Second. Jackson? Okay. Huh? Johnson, got it. Sorry, I don't hear well. Okay. Hiley, right? Okay, coming across, there you are. All right, good deal. Okay. So there's many ways to do it. I did it that way because that's the way that makes the most sense to me. If it doesn't make sense to you, if some other way makes sense and you get the right answers, use it. You're not stuck to this method. Okay? How about the B here? What do we notice here? Say again? Something about a 1. Oh, it's over 1. Got it. I got you. Okay, now, what do we need to do? Say again? Common denominator, and what will it be? 5x. You're absolutely right. What do I have to multiply that first one by to make it a 5x? By 5x, right? If I multiply the denominator by 5x, what did I better do? Numerator by 5x as well. So what does it become? 5x squared. Perfect. Second denominator, what do I have to multiply by to make it 5x? 1. Or you have to multiply by anything. It's already 5x. You're absolutely right. So multiply the numerator by 1 as well, or just write it down as 3. So what do we have as our answer? 5x squared minus 3 over 5x. Is there anything else you can do? Absolutely not. Okay? 5 is not a perfect square. 3 is not a perfect square. That's not a difference of 2 perfect squared. You're done. That's it. All right. Any questions on that? All right. Let me clear these out of the way if there are no questions, and let's see how the book did it. All right. The LCD for that first one, the A one, is 12x, just like we saw. And what they did, basically same thing we did, they just wrote it in a different place. To get this one to be a 12x, this one to be a 12x, they multiply by 12, numerator and denominator. Why do we multiply by numerator and denominator? What is 12 over 12? 1. And where can we multiply by 1? Anytime we want to. It doesn't change the value at all. Multiplying by anything else is going to change the value. We don't want to change the value, we just want to change how it looks. Okay? So, that gave us that. Just like we did before, to get this denominator to be a 12x, we multiply by 4, but multiply the denominator by 4, we multiply the numerator by 4. Get this to be a 12x, multiply by 3. If you did that to the denominator, you have to do it to the numerator as well. Okay? So that gave us 12x over 12x minus 12y over 12x minus 16y over 12x plus 9y over 12x. When you combine those together, how I like to do it, you can do it any way you want to. I like to add the positives together first, and that gave you 21 minus 16 is 5y. However, you could do it brute force and just go minus 4y plus 9y is plus 5y. Either way you want to do it is, as long as it's correct, it's fine. And that's what they did as well, sort of, and got 5y over 12x. Any questions? All right. Good deal. Let's do the B part. Here, the least common denominator, as you noted, because this is over 1, is 5x. Okay? So you multiply the first one by 5x. But if you multiply the denominator by 5x, you must multiply the numerator by 5x. And this one you don't have to multiply by anything, leave it alone. And that gave you 5x squared over 5x minus 3 over 5x, which when you combine your common denominators, and this is why you get common denominators. When you're adding or subtracting these common things with the same denominator, just add or subtract the numerators, keep the denominator. And that gives it to you. Any questions? Does it make sense? Got it? All right. Now, flip the page, and you'll see a check your understanding number 4. Another add, subtract, A and B, just very similar to what we just did. Please do those as soon as you can after class. If you're going to one of the lab things, if you haven't done it before then, please do it right away to remind yourself of how to do that. Now, there's another focus here. Does our text show it? No, it doesn't. Or the slide set doesn't show it. Text does, but the slide set doesn't. So let's do the next focus. The A part here is 2x over 2x minus 3 minus 1 over x plus 1. Okay, how in the world are we going to do that? It's an adding or subtracting of rational expressions. How do we do it? Common denominator. What is common between 2x minus 3 and x plus 1? Huh? 1. That's about it, too. Okay? This is science, right? Okay? Just got to find you. There you are. Okay. We're in Module 12, Section 12.2, Objective 12.2B, I believe it is. Okay? And it's on Module 12, page 12. Okay. Oh, and by the way, it was determined last Friday that a lot of the instructors had obviously gotten together and decided they really did not like this text. What do y'all think of the text? You don't like it either? Right. So they decided they didn't like it either. They, when we were going to this new way of doing things, y'all probably don't realize it was new because this probably is your first term here. But before this, we didn't have these supplementary labs. We had a Math 090, a Math 098, and a 100. 090 was basic math, 098 was elementary algebra, and this was intermediate algebra. They decided to do away with the basic math, the 090. So they combined 090 and 098 together and they combined some 098s with 100. So they wanted to have the same book for both of them. Before, developmental had their book and college math had their book. So they wanted to combine these together. So we had to go to a new book. And the book company that the administration loves said, this is the best book for it. This is the only one we got that covers all this material. So we said, okay, I guess we have to adopt it then. And we didn't have much of a chance to review it. But then after teaching it for half a term, the instructor said, yeah, can't we find something better? And they did find something better by the same company, but it's a much better text. However, I hope none of you have to repeat the course, but if you do, if something happens in second mini term that you have to withdraw or something like that, I think we'll still use this text so you don't have to get a new one, a different one. Would that make any difference to you now that they do the whatever they call it, Cengage, whatever they call it?
You can't hardly get into your themes.
Yeah. So.
I can only get like this.
Right. So, none of you purchased the book, or you just rented it, or whatever. Is that right? You did purchase it. Okay. I figures that some people probably did. So therefore, we're going to stay with this for the Math 100 because the 098 students have this text. But the 098 students starting in the fall, in the spring, will go to the new text that we're adopting. So anyone that's in 100 in the spring will still use this text. And therefore, if you bought the text and don't need it anymore, what you can do is probably sell it to someone who's going into 100 in the spring. So y'all have that advantage. After spring, though, no 98 and 100 will be in the new text. Okay, that's just a little side note. Okay, what we was discussing, least common denominators here. What did y'all decide? What do they have in common?
Can you flip? You can't flip it, can you?
What's that?
You can't flip those. Your thing.
What you mean flip them like
you
this?
can't put, yeah, like can you turn?
Okay, if that was a division sign, that'd be exactly what you did.
Okay.
This is a subtraction sign, though. So we're looking for least common denominators, as y'all already said. Is there a common denominator between those two? No. So what is the common denominator then? Well, there is one, obviously. But there's nothing common between those two, no common factors. So let me put it that way. So what do we have to do? Multiply them together to get the common denominator. So the common denominator is 2x minus 3 times x plus 1. But if you did that to the denominator, what had you better do? Multiply it by the numerator as well, x plus 1. And this denominator over here with x plus 1, so what do we have to multiply it by? 2x minus 3. And you see, now they have the same denominators. But if you multiply that one by 2x minus 3, what did you better do? Numerator by 2x minus 3 as well. Okay, let's take a step to rewrite that. What's the first numerator going to be? Distribute. 2x squared. Go on. Plus 2x times x is 2x squared. 2x times 1 is 2x. And then over here we have a minus 1 times 2x. That would be minus 2x. And minus times a minus 3 is plus 3. Now, was that too many steps at once? Okay, what we did here, we distributed here. 2x times x is 2x squared. 2x times 1 is plus 2x. Here we distributed the minus 1 across this, and that became minus 2x. And distributed the minus 1 here, and that became minus 1 times minus 3 is plus 3. Now, if it helps to take another step, to write it out differently, whatever it takes for you to see and understand that, do it, okay? Does everybody see what we're doing here? Okay? Now, all that is over our common denominator. No reason to write them twice now. We got a common denominator, 2x minus 3 times x plus 1. And it doesn't matter which order you write them because multiplication is commutative. What can we do to that numerator to simplify it? Combine like terms, and what happens? The 2x's add to 0, so you're left with 2x squared plus 3 over, and there's no reason to multiply those together that I can think of, 2x minus 3 times x plus 1. What do we do next? Can we factor? We got the denominator factor, that's why I said no reason to multiply it. How about that numerator? How about that numerator? What you think? Will it factor? Yay or nay? Will it factor? Numerator? No! It's relatively prime. It's a binomial. The only way a binomial factor, except for factoring out common terms, which it has none, is by sum or difference. Difference of two perfect squares or sum or difference of two perfect cubes. Though x squared is a perfect square, 2 is not and 3 is not. So, and that's a sum. So in all three ways, that cannot be factored. Okay? So we have our answer. Let's see how the book did. 2x squared plus 3 over 2x minus 3 times x plus 1. Good for them. They got it right. All right. There's a B part here. Oh, here it is. I lost it there for a minute. So this is the A part. Here's the B part. Is x plus 3 over x squared minus 2x minus 8 plus 3, I can't write, over 4 minus x. What do you reckon we're going to do first here? Your cue. Factor! All right, this time we do factor first. Why? This looks like it can be factored. And in order to get common factors, you have to know what the factors are. So let's see if we can factor this. We may not be able to. That's fine if we can't. But let's see if we can. What would be the only possible factorization for x squared? X times x. Got it. Then we look where? Sign of the last term, and that's negative, and that tells you about what about these two signs? Yeah, negative and positive, okay? Now, we want two numbers, because those are different signs. We want two numbers that multiply to be 8, whose difference, because they're different signs, is 2. Say again? 4 and 2. And who wins which sign? 4 is the negative sign, and 2 is the positive sign, because the minus sign in the middle means the minus number is the larger. All right. Now, did that help any? Only a little bit. Because I don't see either one of these factors there, do you? But you see something fairly close. What? And how can you make that look like one of those? Take out a negative 1. Factor out a negative 1, which will then make that plus a minus, not a times. That makes it a minus, and reverse these two and make that an x minus 4. All right. Now we look like we could come up with a least common denominator. What would it be? X minus 4 times? Help me. X plus 2. This one already has that, so I'm going to write it down just like it is. X plus 3. Okay? Now, this one over here doesn't look like that, so what do we have to do? X plus 2. But if you multiply the denominator of x plus 2, what did you better do? By x plus 2. All right, so I've written down the first numerator, and then let's distribute the minus 3 across the parentheses, and what do we get? You tell me. Help me. Minus 3x. A little louder. Help me. Minus 6. Excellent. Over our least common denominator, which is x minus 4 times x plus 2. Now what do we do? I'm sorry? It's a 2. It's a plus 2. It's an ugly plus 2, but it is. Okay. All right. Next. Anybody? A little louder. I wouldn't factor yet. Combine like terms, okay? And what like terms do you see? And what does that give you? Yeah. Negative 2x minus 3. Okay? That's not common to anything in the denominator, so we just write it down like this. Okay. Now, If people don't like having a bunch of minus signs in the numerator, which it really doesn't matter, but I could easily see that someone doesn't like the way that looks, you could write that as a negative 2x plus 3 over x minus 4 times x plus 2. Okay, my pen messed up on me a little there, so let's see if I can correct that. Now, you don't have to change this. This is just, I'm just saying if you didn't like minus minus up there for some reason that just irritated you or something, you could factor out the minus sign, leaving the 2x plus 3, but the minus sign is now in front of the whole fraction. Okay? There's no reason to do that, but that is a correct answer. That is a correct answer. Either one of those are acceptable answers. Okay? Whereas if you were doing the advanced web assign, it would only take one correct answer and call all the others wrong, even though both of those are perfectly correct. Let's see what the book did. They left the minus signs in there. So they did minus 2x minus 3 over x minus 4 times x plus 2. Any questions? All right. There's a check your understanding 5, similar to the ones we just did. Please do those as soon as you can after class. And then there's 6 practice problems. Please do all those just to get the practice done. Now that is the one thing the instructors didn't like about this text. There's just not enough practice problems. Okay? And so that's the gripe they had. I conclude or concur with that thing. There really isn't enough in here. They're trying to force you to use WebAssign, I think, or I don't know what they're trying to do. But anyway. All right, any questions before we move on? Everybody got, okay, still getting it? Okay. All right, got it? Everybody? Okay. This was the previous one. And that's the end of 12.2B, or not. Okay. We'll discard that and go to 12.3A. All right. We'll try to go to 12.3A. And it's still trying to go to 12.3A. In fact, this is the only 12.3 we have, so why they call it A, I don't know. All right, so let's go to the slideshow, current slide. And here we have Module 12 again, rational expressions. I'm glad they gave us that slide again. It's so pretty. And then we have now, for Section 12.3, complex fractions. And the objective 12.3A, even though there is no B, is how to simplify complex fractions. Now, let me back up just a bit. What do we mean by complex fractions? Frankly, I don't like the term. Because in math, when you say complex, usually that connotes to most people you have imaginary numbers or parts in it. We haven't done those, and we're not going to do those, I don't believe. So that's, I think, the wrong use of the word complex. What they mean is complicated. If fractions aren't complicated enough, these are more complicated fractions. These are fractions containing fractions in both numerator and or denominator. So that's what they mean by complex fractions. So how in the world do we go about simplifying these? Okay? Now, part of this, you need to remind yourself what a fraction is doing anyway. What does 1 over 4 mean? 1/4. Some people call it 1/4. That would be fine. What does it mean? Okay, I like to think in terms of food. Okay? I like to think of having fantastic apple pie there. And I divide it into 4 pieces. And 1/4 of it would be mine. No, it would be 1/4 of the pie. Okay? 1/4 of a pie, right? Okay. What do? You divide it. So fractions are actually dividing things. That horizontal bar is a division line. Okay, I think y'all all knew that, but just to reinforce it. Complex fraction is a fraction whose numerator and or the denominator contains one or more fractions. Okay? So that's what they mean by complex. I like to call them complicated fractions, as if fractions were complicated enough. So here's examples. Okay? Here the numerator is just a number, but the denominator of this fraction form has a fraction in it as well. Okay? This is just a number, but this is then a fraction within the denominator of fraction. Here, we have a fraction in the numerator and a fraction in the denominator. So how do we go about simplifying these? Okay? There's a couple of ways that you can do some of these. One way works on most of them better than any other, I think. But if you like the other ways, you can certainly do it. And that would be, look for the, guess what? Least common denominator of all your denominators in the fraction. What's your denominator in the numerator? 1. Denominator here? 1. Denominator here? 2. Okay, what's the least common denominator there? 2. No, 2. Common. Not just least, but common. So what do we do with it? We multiply the numerator and the denominator by 2. In other words, you're multiplying by 2 over 2. Can you do that? 2 over 2 is 1. Can you multiply by 1? Sure you can anytime you want to. So they're not asking you to do this now, but I'm going to do it for you. Okay, let me get my pen back. Multiply this one by 2. Multiply this by 2. Okay, because 2 over 2 is 1. What's the new numerator? 2 times 3. 6. Okay, the new denominator. 2 times 2 is, you're distributing. 2 times 2 is 4. 2 times negative 1/2 would be, oh man, 2 times negative 1/2. Okay, take that pi, cut it in 2, and subtract 1 from it. You have minus, yeah, okay, that's a minus 1. Okay, 1/2 left. 2 over 2 is 1, so that's 4 minus 1. So this would be 6 over 3, which is 2. Got it. Okay? That's your simplified form. They all won't be that simple, but they will be. So guess what we do to the next one? Anybody? How do we start the other one? Least common denominator. So what is least common denominator? All the denominators in that one, what would it be? Anybody? What's the only denominator in the denominators? X. Okay, I can't hear. So what do? We multiply numerator and denominator by x, which means x over x, and that's 1, right? So in the numerator, what does that new numerator become? Distribute the x, and what do you get? 4x plus 1. Excellent. Over 3x. Help me. Plus what? Anybody? 2. Excellent. Anything you can do to simplify that? Not a thing. Don't even try it, okay? Can't factor it. You can't divide out anything that's not multiplied and it's not factorable. Guess what? Whereas fractional forms are division. When you factor, you're dividing as well, and those becomes your multipliers. So anyway, they didn't ask us to do that, but we did it anyway. No extra charge, by the way. All right. Now, in your text, they had those two, and they have another one. Let's see if they have it on the next slide. No, they don't. Okay? So let me delete from this slide and do the third one they have here. okay? That's 1 over x plus 1, wow, plus x plus 3 over x minus 3 plus 1 over x plus 4. Okay. Ooh, do we really want to do this? Sure we do. Okay. Where do we start? Least common denominator of all our denominators, and what is that going to be? Yeah, you do. It's one like one we did a short while ago. When you had nothing in common, what do you do? Multiply them together. That's your common denominator. If your denominators had been 2 and 3, say, if those had been denominators, nothing in common, so we multiply them together to get 6, right? Same thing with expressions. If there's nothing in common, multiply them together. So, the numerator will multiply by, it's going to be a little more complicated, x plus 1 times x plus 4. And the denominator we multiply by x plus 1 times x plus 4. All right. Now, what we're going to do is multiply this by that, right? Distribute this to each one of those 3 terms, right? All right. Now, when you multiply this by this, what happens? The x plus 1 divide away, and you're left with a numerator of just whatever that is, x plus 4. Can't read it. X plus 4. All right, so that first part of the numerator is going to be x plus 4. Now here's where it gets a little messier, okay? Plus x times, and you got to multiply those two together, right? Don't you? Because there's nothing to divide out. And this time we do multiply together. In the denominators we leave them factored. In the numerators we have to multiply. So let's FOIL these, and what do you get? X times x, x squared, plus 4x, plus x is plus 5x, and 1 times 4 is plus 4. So that x is going to multiply by x squared plus 5x plus 4. Okay? And then that plus 3 multiplies by the same thing. You've already done it. Write it down again. X squared plus 5x plus 4. All right. And all that is over. We've got to do the same thing to the denominator. But guess what? Same fraction here. So that's an x times x squared plus 5x plus 4, right? Because those two things multiply the same as those two. They're the same thing. Minus 3 times x squared plus 5x plus 4. And then that last fraction, how does it multiply? So we multiply this by that, we multiply this by that, now we multiply this by that. What happens? X plus 4's go away, and you're just left with a x plus 1. So that just leaves us a plus x plus 1. Now you got a bunch of distributing to do. I know this is a pain in the neck, isn't it? But needs to be done. Okay, so let's just start. X plus 4. This is the numerator. Distribute that x across and tell me what you get. A little louder. X cubed. Everybody see that? Plus 5 x squared plus 4x. Keep on. Plus 3x squared. Keep going. Plus 15x. Is that what I heard? Yeah, it should have. Okay.
Oh, I see.
Okay. And then finally, plus 12. All right. Okay. Let's do the same for the denominator. What does that start with? x cubed plus 5x squared plus 4x minus 3x squared minus 15x minus 12 plus x plus 1. Whew. A bunch of combining like terms to do, right? I only see one cubic term in the numerator, so that's going to be x cubed. I see two square terms, that's going to be, tired already, huh? Plus 8x squared. Okay. I see three x terms. 1, 2, 3. What do those combine to be? 20 plus 20x. Okay. And then I see two constant terms. And what do those combine to be? Plus 16. Okay. Ooh, wow. Okay. Well, let's do the same for the denominator. I only see one cubic term, so that's x cubed. I see two square terms, that becomes 2x squared. I see 3x terms, and that becomes, help me, negative 10x, exactly. Okay, and then I see two constant terms, and what does that become? Negative 11. Okay, now they didn't ask us to do this. We're doing it because we enjoy doing this kind of stuff, right? Yes, okay. Sorry about that. Now, the next thing we would do is try to factor both of those. And the only way we have of factoring a four-term polynomial is grouping. After you remove common factors are any common factors, okay? And if you group these two and those two, all you get out of this is an x squared, and you're left with an x plus 8. There's no way you're going to get x plus 8 out of that. So that will not group. It will not factor. Hang it up, Jack. Okay? This one, same thing. This will be an x plus 2 times an x squared, and there's no way that factors into anything. So it's not going to factor. That's your simplified form. Okay? That's all you can do. They didn't ask you to do this, but I'm just showing you this is how you do it. Now that you got these done, you can do just about anything, I think. So let's do one more. And this will even be, I think you'll find it fairly easy. Can I erase this or anyone still writing? Okay. So let's do the one they say in the book. All right. I'm going to do it out here on the side here. 1 minus 4 over x squared over 1 plus 2 over x. Okay? What would be your suggestion of what to do first? And how in the world did that 1 in the denominator get across through it? I do not know. That's a 1 plus 2x. My pen must have drug or something. I don't know. Okay. What's be your first step? Oh, yeah. And what would that be? Anybody? X squared, of course. And what do we do with it? Numerator and denominator by x squared. Okay? I think I can do the first one. X squared times 1 is x squared. And x squared times a minus 4 over x squared would be negative 4. Excellent. Okay, everybody see that? Yay or nay? Okay. And by the way, I know you're not leaving, but it just reminded me. If anyone does have to leave early, do not leave before you pick up a quiz. Okay? So, just wanted, because I know sometimes I have people who have a class on the other campus or something and have to leave early. Okay, what happens in that denominator? X squared plus, what'd you say? Did I hear a 2x? Is that what I heard? It was a 2x, okay? Now, what happened there, and take your time. Take as many steps as you need to show this. X squared times 2 over x. The x will go into x squared. X times 2 times x is 2x. Perfect. Are we through? Why not? Say again? Still what? You're probably saying right. I just can't hear.
We still have an x squared in the top and the bottom. So
Okay.
Can we not factor it?
Yes, that's the thing. Whether you have x squared or not, try to factor it. Will that numerator factor? We hope so. What would it factor as? Say again? The whole numerator. X minus 2 times x plus 2. Anytime you have a difference of two perfect squares, it's the sum times the difference. The two conjugates multiplied together. Okay, how about that denominator? Factor out an x, and what are you left with? X plus 2. Right? Now what can we do? Yes, it is divide out the x plus 2's. Absolutely right. And what you're left with? X minus 2 over x. And that is probably the answer they give. Now in this one, again, I don't mean to confuse you, but I'm just telling you, there is another way you can write that answer. We can undo a subtraction and make that as x over x minus 2 over x. Common denominators and do that, and this would be 1 minus 2 over x. Now that's no better, nor is it any worse than this answer. Either one of those answers fine, you'll get full credit for them from me. Whoever signed, you wouldn't. Okay, one of them's going to be right and one wrong. They're both right. But you don't have to go that extra step. That to me is a perfectly fine answer. And what did they get in the book? X minus 2 over x. Very, very good. Any question? Okay. Now, I wasn't paying close attention to what they did there. They did it the same way we did. They show you on the next page, this is page 14. Oh, you got to go? Okay. Enjoy. People who leave early get the hard ones. Okay. No, I'm just kidding. Okay. All right. How are we doing on time? Second? 10. Oh, we got plenty of time. All right. They show a second way of doing this, and it's perfectly okay to do it that way. If you like it better, go for it, folks. I'm going to wait until there's one that's obvious to show you that next method. And I really don't see any that it's no better, no worse. In a few circumstances, it's actually easier to do. Very few, though. So you can look at the top of the next page. That's page 14 of Module 12. They show another way to do it, and it's perfectly okay to do. It, to me, takes longer and more opportunity for error, so I don't like it. But you can do it. It gives you the same answer. Okay. So now we're going to focus on simplifying a complex fraction. And this is the right focus. Sometimes they skip one. So let's do the A one first. What would be your suggestion of what to do first? This one right here. Common denominator of all the denominators, both the numerator and denominator, what would that be? Anybody? The least common denominator of all four of those denominators. Okay? 2x, but x squared won't go into 2x, 4 won't go into 2x. Or x squared. X will go into 4x squared, 2 will go into 4x squared, x squared will go into 4x squared, and 4 will go into 4x. Yes, that's common to all of them. So the least common denominator is 4x squared. What do we do with it? Multiply numerator by 4x squared and denominator by 4x squared. And you notice what we're doing then? Multiplying by 1, which is legal in most states. Okay? So what do we do from there? The first one, when you distribute this, 4x squared times 1 over x, what does that give you? (4x squared times 1 over x). Okay, let's write this out. 4x squared, this is a little bit longer to do it this way, times 1 over x, plus 4x squared times 1 over 2. Is this going to be helpful to do it this way? Do you see it better? 4x squared times 1 over x squared minus 4x squared times 1 over 4. Does that help you see what we're doing better? Okay, we're distributing the 4x squared in both of those parentheses. That's what we've done. Okay, in this one, that first one right there, what do we do? 4, yeah. Say again? Just 4x, yeah, because this x goes into one of those x's, and you're left with 4x. So the first numerator becomes 4x. Okay? Next, the 2 will go into 4. 2 times, that'll be plus 2x squared. Perfect. Next one. No, see the x squareds go out. They've been dating, okay? And this leaves you just a 4. Okay? And it's just a minus x squared. You see it? Because the 4's go out. Okay? Leaving a minus x squared. Does that make sense? Does that help you see that distributing a little easier? Okay. All right. Do that if you need to. It's perfectly legitimate. Are we through? What can we do? Factor. All right. Good. Okay. Numerator. How will it factor? Anyway? Will that numerator factor? How? 2x. Factor out the greatest common factor of 2x. What's left in the first term? 2 plus x. Perfect. In the denominator, will that factor? Say again? How? Say again? Okay. All right. There's no x in both terms, so I don't think that's what you're meaning. Okay. Not quite. You reversed it. It's 2 minus x times 2 plus x. You flipped it around, right? Okay? Does everybody see that? That's a difference of 2 perfect squares, right? 4 is a perfect square, x squared is a perfect square. This is sometimes the difference of those 2 square roots in those orders, okay? Now what you notice you can do? Divide out the 2 plus x's, and that leaves you with 2x over 2 minus x. Can you do any more? No. Now you can write it differently if you don't like having it in descending order of the powers. If you want that x minus 2, which it sounded like you did, then you could factor out a minus 1 and make it 2x over x minus 2. That's perfectly correct. It is a perfectly good answer. This one is just as good. I tend to like this one more because I didn't have to do it much, okay? And I'm lazy. But you can factor it out if you wanted that to be a descending order. Okay? Both of those are good answers. Both of them are correct. Next WebAssign would only give you credit for one of them and tell you the other was wrong where it wouldn't be wrong. And they leave it in the first form, which I think is perfectly fine. All right. Any questions on that? All right. I think we can get the B done, don't you? Yeah, sure we can. Let's at least get it started. Can I erase this one? Anyone need it up there a little longer? Yeah, someone's still writing. Okay. So we may not do the B yet. Everybody finished with this? Someone still writing? Okay. All right. Everybody got it? I see one pen still moving. Pencil. Got it? Good deal. Okay. What I'm going to do is skip over and show you the A solution, not the B solution. Ooh, I'm going to have to erase this. Just so you can see how they did it, to see if you like their way any better than mine. Okay. What they did was find least common denominator, which was 4x squared. They multiplied it by numerator and denominator, and they distributed a lot like we did, only in reverse order. And then when you did that, you got 4x plus 2x squared, just like we did, over 4 minus x squared. And then they factored out of 2x, and they factored the difference of two perfect squares. Divided out the 2 plus x, got the same answer, same way we did. So we'll pick up next time and do the B one, okay? And you can start working on some of those, check your understanding 1 if you want to, and the 2.3A practice, which is there. We haven't quite done all those, so you don't have to. Let me get you the quizzes before you go. I had to do this on 2 pages because these took too much room. Can I get you to take one and pass one? Pass one and take one. It's 2 pages. One is pass 2. Pass. One is read. Take one and hand it the other one. And take one and pass one. I think it's 3. All right, you get one. You take one and pass 2. Take one and pass 2. Take one. Take one and pass 1. Take one and pass 2. Everybody got one? Good deal. Okay. Now, technically, these are due a week from today. That'll be next Monday. If you need more time, you can have it, but get them in well before the next test. And by the way, if anyone's missing a quiz, like the second quiz, please get that in so you can take your second test. I think I'm preaching to the choir here because I think all of you have already got it. Okay. All right. Good deal. Any questions?